So then we've already seen that if we declare a new variable that's of a particular type, then we can't change that type later on. So TypeScript automatically figures out the type of this variable by looking at the value we assign to it. And this is known as type inference, where the type gets inferred by TypeScript based on its assigned value. It knows this is a number, so it applies the number type to this variable. But as well as types being inferred this way, we can also explicitly assign types to variables by using type annotations. The way we do this is by writing the variable name, then a colon, and then the type. In this case, it would be a number. And then we can optionally give that a value by setting it equal to something. And the benefit of type annotations like this is that it's easy to see at a glance what type something is, especially if we don't give that variable an initial value and we just want to declare it however. As you start to feel more comfortable with TypeScript, you're probably going to find yourself dropping a lot of these explicit type annotations, relying instead where possible on TypeScript's type inference. For this course, I'll be annotating a lot to begin with, and then later on maybe I'll start dropping them here and there. Anyway, let's go through some examples. So then we've seen that we have this age, which is a number. Let me just show you quickly. If I try to say that age is equal to a string, for example, hello, then we get this red squiggly line that says there's an error, and if we hover over that, it says type string is not assignable to type number. So this can only be a number in the future. Now we can change the value of that number. It can be 31 or something else. So that doesn't matter, just that it is a number, okay? All right. So let's add some more variables up here. We'll say let first name be of type string, so colon, then a type, which is string, and set that equal to Mario. Let's also do a property called is fictional, and we'll set that to be a Boolean. So colon, Boolean, and in fact we won't give this an initial value. We don't have to, we're just setting the type of this. So now if we try to say first name is equal to something different, like a number 100, we're going to get an error. It can only be a string because we've assigned it the type of string right here. So we could change it to Luigi, that would be fine. And then if we go to is fictional, let's say is fictional, like that, and let's change it to a string that says false. Now, that's not really a Boolean, that's just a string false, so we can't do that. Instead, it has to be an actual Boolean, which we're allowed to do. Alright, cool. So, let's look now at also type inference a little bit more. So what I'm going to do is create a few variables. I'm going to say let planet equal to Earth. Why not? And then we'll say let moons equal to 1 because that's how many moons we have. And then we'll say let is large be Boolean, which is false. Alright, so we've created 3 variables now, and TypeScript automatically infers the type of each of these. So if we hover over them, you can see the type that is inferred. So the planet is a string based on this value. Moons is a number. Is large is a Boolean. So now we can't change those types either. So I could say planet is equal to 10, and that's not going to be allowed. We get that error. But I could say that planet was equal to Saturn. Oops, not Saturn, Saturn. And that is allowed. I could also say moons is equal to string 145. And that's not allowed because it's still a string. But we can change it to 145 as a number. That is allowed because the initial type was a number. And finally, I'm going to say is large and set that equal to yes as a string again. Not allowed because the inferred type is a Boolean because we set the initial value to be a Boolean. So we'll just set this to be true instead, and that is absolutely fine. So there's 2 more types I quickly want to show you, which are null and undefined. And both of these types represent a lack of value, but there's a small distinction between them. When we give something a value of null, we're intentionally providing the absence of value to it. But when something's undefined, that's more of an unintentional lack of value. So for example, when a variable is declared, but no value is assigned to it, in that case it would be undefined, right? So both of these values in TypeScript have their own type associated with them. And again, once we've explicitly assigned a null or undefined type to a variable, it cannot be changed. So I could create 2 new variables, one called something, which I could assign a type of null to, and another called, I don't know, another thing, which we could then assign a type of undefined to. And now both of those types are locked in, so those variables can never take another type of value in the future. So if we try to give the something variable a number value, for example, then we're going to get an error because we're not allowed to do that. Its value can now only ever be null because we defined that null type. So we can set it to null as the value, and that would be absolutely fine because null has a type of null. The same would be true for the other variable, another thing. If I tried to give that a value that wasn't undefined, like a string, for example, then it's not going to let me do that. We get an error because the undefined type is now locked in, and that's all its value can ever be. Now, although it might be the case that you probably give a value to a variable which is null at some point to kind of signify a lack of value for that variable. For example, if a user logs out, you might want to hold a value of null in a variable to represent that lack of user. It's probably going to be quite rare that you explicitly type a variable as undefined. It's probably more likely that at some point you declare a variable but don't assign it a value straight away, and then it gets a value of undefined to begin with, alright? So that's some of the basics out the way now. Next up, I want to talk about how we can generate a tsconfig file to make our workflow of compiling the TypeScript a little bit easier.